Good morning. Can anyone hear me? Just about, if you're in the front. Hello. Wave if you can hear me. Good. Excellent. Right, we go. Welcome to a damper than usual Rail Live. Apologies on behalf of my editor who promised good weather. We are here this morning to talk about hydrogen and the future of hydrogen in the UK rail industry. We'll get going pretty quick. So what I'm going to do, I'm going to ask our panel to introduce themselves, but not only say who they are, but also ask you to just sort of say who you are, where you're from, and also why your business works with hydrogen in the rail industry. So if we start.
Good morning, everyone. I'm Mark Downing, Head of Industrial and Energy at Heavy Haul Rail. We, under our previous branding, were working with GeoPura and Network Rail to move the UK's first shipment of hydrogen by rail. And obviously we're here working with these guys to try and make sure that the message goes out that it is possible and that it's ready to go. And yeah, let's get moving it.
Good morning, everybody. Ben Ackroyd, Chief Operating Officer at Porterbrook, and welcome to Longmarston Rail Innovation Centre. So, yeah, our involvement in hydrogen, I mean, we're an asset owner of over 4,000 rail vehicles in the UK and one hydrogen train, which is obviously on site here today. So our interest is very much from a rolling stock application perspective and, you know, the future potential for small fleets of hydrogen trains.
I'm Charles Calvert, Chief Innovation Engineer at Vanguard Sustainable Transport Solutions. We're a spin-out company from the University of Birmingham's hydrogen train team. So 7 years ago, I was on Hydroflex 1 as the test engineer. I wasn't allowed to see daylight, which might have been an improvement over present state. But yeah, I've been working in the hydrogen field for the last 9 years. In terms of the why hydrogen, we got involved with it for 3 reasons. In ascending order, for the global warming reasons, the global emissions, local emissions, but most importantly, national security, energy security. And we're going to talk more about that as we go along.
Fantastic. And Matt Barney, so Chief Hydrogen Business Officer at a company called GeoPura. So GeoPura, we were founded back in 2019. Seems a long time ago now. Little startup, just 3 of us initially, but we've grown to well over 200 people. We've had a fantastic big brother, though, from day one in Siemens Energy, who've been our collaboration partner and who are a shareholder in GeoPura. Our interest really is trying to develop commercial. The word commercial is really important, central to everything we're doing, in the hydrogen space. So zero-emission fuel technologies, we're interested in using all of this wonderful curtailed energy that the country is currently wasting and turning that into a resource which gives us all the benefits of those wonderful old things, fossil fuels, but of course with all the benefits of no emissions. And we've been doing that, deploying hydrogen power units built here in the UK by Siemens Energy, range of customers and range of different markets displacing diesel generators. That led us to run out of hydrogen, would you believe? So we've also got very involved in the production of hydrogen, producing across 4 sites, and currently Europe's largest producer of low-carbon hydrogen. And it's fantastic to be here today.
Great, thanks. So, I mean, those of you who are coming through the main entrance, might have seen the heavy haul locomotive with the 2 hydrogen containers behind it. There is some hydrogen, I think, generators around today as well, and there's the Hydroflex, of course, that's running. So, first of all, if we start maybe with you, Matt. So, I mean, what opportunities do you guys see for a greater use of hydrogen on rail in the UK over the next few years?
Yeah, so a bit like really in all areas with hydrogen, you know, everybody's known for a long time that hydrogen probably has a really important role to play in helping us do all the things we love doing with this fantastic energy, but on a renewable and a sustainable basis. And of course, with fuel security at the moment, that's even more paramount, with insecurity about where we get our old fossil fuels from and whether we're still going to have those supply chains. So in that ecosphere, our interest is broad and wide, but specifically with rail. In recent times, so we've reached a scale at GeoPura where we're deploying our hydrogen power units to displace diesel generators right across the country. But we're now working on some very large systems. So we're actually building systems that can support 50, 100 megawatts of power. To do that, you need a lot of low-carbon hydrogen. Now, we're in the fortunate position where 2 of our production sites happen to be on old coal-fired power stations, which of course have a wonderful connection to rail, with all that coal that was brought in, dug out of our pits in Nottinghamshire and taken by rail into our coal-fired power stations. We've got another one down as well at Port of Tilbury. We have the potential to build on where we're at, which is still small, Absolutely, it's currently the largest in Europe, but the big picture of how much energy we're all using in any application, not least rail, it's still small fry, but we can scale very, very quickly from where we're now at. And the lovely thing about these locations, they happen to be located on rail networks because of that old coal and power station legacy. So we'd love to help rail transition for basically twofold. One, getting our own hydrogen from A to B to our own assets. So until pipelines become a thing and a reality with hydrogen, at the moment we're moving everything on the roads. We'd love to be being much more efficient in our distribution, particularly to heavy intensity energy uses like data centers, and use the rail infrastructure to do that. But at the same time, if hydrogen exists and is being used to be moved around the country, why could it not be used in rail? And that's where it's brilliant with folks like Vanguard and Heavy Haul. They've got aspirations to start using hydrogen at scale. That opportunity is beginning to exist.
Yeah. Mark, do you want to follow up? Because if you're working with GeoPura...
Yeah, certainly. So, as sort of Matt alluded to there, obviously, energy has always moved by rail. You've got coal, you've got fuel. This is the next energy process that can be put onto rail at scale. And it's as simple as, like I say, out at the very front of the facility here, there is an example of it being done already. So it's a simple case of linking up with the production facilities, the end users, and the range of those end users is quite astounding, to be honest with you. You look at some of the posts of the guys from GeoPura, the range of different opportunities that they're exploring. But then you also add in some of the larger commercial scale things that are the future potentially. So if you have steel production that is using hydrogen, if you have energy systems either in your home or domestically or in infrastructure, there is a huge opportunity there, and rail can move it easily. And you mentioned pipelines. As everyone knows, it is challenging to build infrastructure in this country. The rail is already there, so we can scale very quickly and we can get it out to customers as of now.
Yeah, I think from a rolling stock perspective, I think hydrogen offers, I feel like, part of the mix around alternative traction types and so on. So it's not, we're certainly not saying it's all going to be about hydrogen, and it's not going to be about batteries. Battery technology is going to play an absolute centre role of traction, effectively, the successors to conventional sort of diesel power, given that the UK electrification is, about 38, 39%, and we know that it's going to take many more decades for that to be rolled out. So certainly acting as an interim measure, and particularly from a passenger rolling stock perspective, you're probably looking at applications out in more rural areas, particularly where they can tap into renewables. I just think, just picking up on a point from Matt as well, it's worth noting is that heavy rail by default requires a lot of hydrogen. So when we talk about starting to get into aggregating demand to sort of break this chicken and egg, well, rail rolling stock could be quite a relatively high consumer in the sense that you need a lot of hydrogen to power a hydrogen train. So a lot more than say 10 bin lorries or a dozen buses or so. So it could play an important role in the overall hydrogen economy.
Yeah, I think you've teed up some of my talking points really, really well. In terms of opportunities, there's the technology mix. Obviously, there's diesel hybrid, there's batteries, and there is hydrogen amongst other solutions. But what I'd like to say is, in terms of the challenge, the opportunity, batteries are about decarbonising and deglobalising applications that are easy. Hydrogen is about doing what is hard. In terms of the fields that I see hydrogen coming into use, the greatest opportunities, there's construction, so on-site power, such as what GeoPura are doing. JCB have made huge investments into hydrogen internal combustion engines. They see that as being the solution for construction, industry, and agriculture for operations that require maximum uptime and minimal refueling downtime. Secondly, there is the obvious, there's the rolling stock, that's where our story began. But not just the vehicles themselves, trains up to the performance probably of a turbo star, but also the logistics behind it, supplying the depots, which is something that Vanguard launched into, supporting the operations of Hydroflex with movement of hydrogen to site and refueling equipment, rail-approved refueling equipment. But also shunting locomotives. We have one that's currently under test and demonstration at Kidderminster. And also heavy haul freight locomotives as well it is possible to do heavy haul freight with hydrogen. CPKC in Canada are demonstrating that amongst other applications. And finally, there is the cargo element. Obviously, there is a fantastic visual display of 2 hydrogen containers on freight wagons here. Thank you, GeoPura and Heavy Haul Rail. But that is the movement of energy on the scale of what used to be done by, with coal, moving coal from ports and mines to power stations. The inverse of that is true. Rail can be the most efficient way, save pipelines, which you have to build, to move hydrogen from A to B. And the infrastructure's there, and the capacity's there to do so.
Okay. I want to move on to, and I'll come to you first, Ben, which is sort of what lessons can we learn from other industries and maybe other rail networks around the world or around Europe? And because you mentioned passenger rolling stock, there is some, there was a recent announcement by Siemens to have some hydrogen-powered passenger trains going to Romania. Alstom has been doing some work with France and Italy, but it's been quite... So are there lessons that are being taken that we can apply to help UK hydrogen use grow?
Obviously there are. I guess, it's had, let's say, mixed success in different parts of the world. It's good to see products that are getting deployed, whether it be out in the US or Europe and out in the Middle East as well. Very different products as well for different markets. So it shows that it's got, in a rail application, there's sort of adaptability. I think a lot of the lessons as well are just to just look at a train or to sort of look at rolling stock, and in fact rail, I think, in isolation is far too narrow, because the thing that's going to make this fly ultimately is cross-sector cooperation, aggregating demand, and actually looking at other parts of the sectors, whether it would be sort of static as well as mobile applications, and how they're evolving the technology to and so on. So I think it does need a really broad look across those other sectors beyond just rail, and I don't think rail can just trigger it and make it work alone, that's for sure. So I think learning those lessons from the other sectors as well as internationally, I think is going to be vital.
Yeah. Charles, you mentioned JCB in there. Are there any sort of lessons that you've sort of picked up from else while working on the Hydro Shunter project?
Again, the lessons learned are you've got to pick the appropriate technology for the challenge. So, as I say, batteries are for the light duties. Urban buses, for example, operate over short distances. The capability of battery buses these days, can meet a lot of these duty cycles. Short hops off the wire, for example, the Great Western Main Line, the short branches off there that are unelectrified, that would probably be best being a battery and overhead hybrid, because they spend most of their time underneath the wires. But it is about those challenging duty cycles. For example, the 22-hour-a-day shunting requirements that our customers often, or potential customers often, come to us with and say, we want a zero-emission shunter, but batteries won't hack it, we can't have the downtime. That's the kind of right application. That's what you need to be targeting as the lesson learned from other sectors for ourselves. And secondly, logistics is everything. This is the standpoint I've taken since starting my PhD. Your hydrogen vehicle, your hydrogen train, your hydrogen digger is useless if it has no hydrogen. And that's where we've been developing the ability to supply hydrogen vehicles at the same rate as supplying those vehicles themselves. We're able to cover Shunter's operation perfectly fine with the arrangements that we've made. So you've got to have sufficient supply and security of supply as well. No single points of failure where if a supply goes down, you're stuck. There needs to be multiple redundant sources of hydrogen, which is a key element of it. Logistics is everything.
Has that got easier as the project's gone on?
It's got easier over time. Back in 2018, I was struggling to source a 220-gram, basically a scuba cylinder of hydrogen. That was a big effort of a company that will remain nameless. We then progressed to supplying 7 kilograms at a time of brown hydrogen. Then we bought our own equipment. We could do 15 kilograms, 2 here at higher pressure. And now tube trailers have been showing up, and you can see many hundreds of kilograms on the back of railway vehicles. So that's the progression that we've seen over time. It has been a probably not exponential curve, if any mathematicians are out there that pick me up on it, but there has definitely been a dramatic curve to the capability that we've been working with, and that leads to a dramatic curve in the capability of what vehicles can do themselves.
Yeah. Cool. And I was just going to, that was one of the reasons why we invested in Hydroflex, and was to learn the lessons effectively, because you wouldn't necessarily just go into ordering a complete fleet and going blind. So the opportunity to be able to both through the construction and the as you say, the logistics of supporting it, understanding what you would need to then do that on a commercial basis out with an operator has been vital. So it wasn't our plan to then build another dozen or so hydroflexes, but actually to use that as the test case to learn from, to be much more informed in future.
Yeah. Matt, from the production and sort of transportation side of it, what have you learned over the few sort of 7 years that GeoPura has been?
We're learning every day.
Yeah.
The systems were initially designed actually to support weak grids. So where there's not enough electrons in your local grid supply and we're plugging in more EV chargers, how do we get a way that can basically remove those limitations so you can plug in 100, 200, 300 chargers and still have the rapid charging function? Turns out there's a whole host of folks that actually can use hydrogen fuel cell technologies and hydrogen technologies. So most of our customers, you'd think would be coming to us because of net zero or because of their carbon emission. That's not the case at all. It's a lovely cherry on the top. But most of our customers, that we've been learning, as I say, every day from, folks like the MOD, where we're supporting across 5 RAF bases at the moment, where there's just not enough grid power on site. Working in construction, Lower Thames Crossing with folks like Belfast Beatty. So quite varied. HS2, again, supplying power. The systems are infinitely more reliable than using the traditional diesel generator alternative. So it creates quite something of a niche. And that's, I think, why we've seen from GeoPura's perspective this growth curve, which has been a bit of a hockey stick. It has been exponential. Now, that created a huge problem. And one of our biggest challenges today has been still, where do you get enough molecules from? It's ridiculous. Hydrogen, the most common element, well, most of our bodies are made of the stuff, for goodness sake, but getting it in a usable form, and certainly a clean form, is not so easy. So we hope the market would catch up quicker than it has in terms of that supply. It didn't, and so that's where we've had to step in. Our shareholders very generously made the funds available to do that. But it's also wonderful on the hydrogen supply side and the transportation side to be working with other partners, folks like JCB. There's a whole host of industry around just the JCB family and different companies and attributes in that. Lots of other players as well looking to now fill those voids in hydrogen supply. So we're taking quite a hedged approach, working with everybody and anybody. Competition, we think, is 10 years away. At the moment, it's about building that scale and also trying to get the competitive advantage for high growth. This is an area of, really, it's a new industrial revolution we're facing around some of our old heritage and legacy industries, these old power station sites that have been so substantial in our economies of the last 100 years. Repurposing all of that wonderful infrastructure to be suitable for the modern day and give us the benefits of highly resilient infrastructure, highly supercritical infrastructure, and reduce our dependency on fuels that we don't know are going to be there for us in the future.
I think the biggest point of view or the perspective from us is there needs to be that almost understanding of what the market can do and how to get to the market. So there are obviously the hydrogen allocation rounds going on for the next couple of years. What is that going to target? Which schemes are that's going to help promote? Because where you see some of the successes in other countries is where there's that large view of it will support this industry, there's a storage capability here. Oh, and by the way, we'll be transporting it from this point to this point. So by having that view and by understanding that there's a whole series of interconnected businesses that are going to be connected by this new product, that I think is the way to really sort of learn and skip some of those teething problems that other places have had.
Yeah, okay. And sort of moving on from that, so we come to you first, Charles. So what hurdles, sort of media hurdles, still need to be overcome? And I know we've talked about supply and that. I mean, maybe some of the challenges I know in terms of like when you've done the hydro shunter, obviously you've had to sort of reconfigure the locomotive and fit heavy sort of metal base plates. So can you talk about maybe a bit about that work and then other challenges that still lay ahead?
Yeah, sure. Certainly, looking vehicle specific, one of the key hurdles to overcome with hydro shunter was the mass of the equipment we were adding. We actually had a large number of debates about whether it was more effective to use concrete or steel weights inside the locomotive when we started the project, because we were thinking in terms of fuel cell and lithium batteries. Then we hit on the idea of using lead-acid batteries for it to get the mass right. So, in certainly the retrofit world, what you try and do is put back in stuff of the equivalent mass and volume of what you've taken out. So having to think differently about how you do things is certainly a hurdle. and there are a lot of hurdles, a lot of things to discover when you physically do a retrofit, things that are hidden as bugs within the machine that someone designed, in our case, 60, 70 years ago, and didn't think that people 60, 70 years later would be messing around with it in such a ridiculous way from their perspective. But I'd say in terms of the whole industry, the key hurdle is perception. I think there is a perception that overhead electrification and batteries will solve all else, and I don't think that's the case. I don't think the money's there for wholesale electrification. Seeing massive political fallout right now about departments being to ask cut budgets for defence spending, for example. So there needs to be that middle way. We need to get over this perception that electrification and batteries will be funded and will happen. And finally, the final hurdle is the need for the country to wake up to the need for proper energy security. There have been a number of nasty shocks over the last half a decade. The war in Ukraine, the war in Iran, the Straits of Hormuz have been blocked for the last few months. I'm former Navy. That was our job. That was what we practiced for, what we trained for, keeping those straits open. And it has recently been proved that we cannot do that. That's 20% of the world's energy supply. That's 20% of what keeps our economy running and keeps prices low as possible. We need to wake up to that and overcome that hurdle of saying we can't rely on cheap diesel being cheap and plentiful forever.
Matt? Did you want to talk about, challenge, yes, hurdles, yeah.
So there's plenty of hurdles,
Yep.
but the joy is, working together and working collaboratively to overcome those. So it's been fantastic. The enthusiasm that we've experienced in the rail industry, which happened quite quickly. Again, it's coming from that real point of this is now commercial. This is a tipping point moment. But the support that we've had from friends at Heavy Haul, from Network Rail, from Vanguard, has been quite phenomenal. So it kind of gives you that encouragement. I grew up under the cooling towers of Ratcliffe-on-Soar Power Station. That's been my view for my 50 years here on Earth. I love power stations. My dad's a former railway engineer. I think to be in the privileged position where together we're now able to begin to overcome these and really do something which is, going to change our ability to stay at the high-end growth curve of global economies and to really change the dial here is just phenomenal. So yes, there's plenty of challenges, and not just in rail, in aviation, in every frontier where we're working. But there's that aptitude, there's that appetite to actually now bring to reality what hydrogen has promised for the last 50 years. Now it can be made real, so it's exciting. The excitement overcomes the challenges.
Mark?
Yeah, I think you're right. One of the major things to start off with is that perception, because the whole project around putting a test case together and moving material by rail started only a few months ago almost. I think it was about this time last year, the Rail Freight Group open forum, where the question was asked, well, how hard can it be? No, it's not Top Gear. It actually was relatively straightforward by comparison. But to get to where we were now did take a bit of buy-in from industry to understand, yes, it moves by road at the moment, why not by rail? And we proved that's possible. I think one of the big challenges from our perspective as a freight mover is what form is that going to take? So is it going to be Meg Cs like we've got out at the front of the stand here in a gaseous form, or is it going to be bound to a liquid like you see in some of the other countries around in Europe? And I think that question then determines what the rolling stock profile looks like, and from there you flow on to what you're going to look like in terms of seeing a bulk train of this material moving around the network, hopefully not very far away.
Cool. I think some of the practical hurdles, such as packaging, like what we've done with Hydroflex, you in that case, you lose a whole vehicle because, to carry 277 kilos, we need, plenty of cylinders. So there are practical hurdles to overcome, but I think we need to be prepared, I think, to put some of those compromises to one side almost and say, well, the way that we've worked with diesel in the past and so on is not necessarily the best for the future and so on, because some of those big picture advantages that hydrogen can bring, I think, can therefore outweigh some of those other compromises. So I think we've got to be open-minded there. And then I think commercially, everybody talks about price, the price point and getting to parity with diesel. I genuinely think it's not that hard. It's not that far away, really.
So can I comment on that? So when we started out at GeoPura back in 2019, we were buying in hydrogen, would you believe, from Europe, and often not green hydrogen, not clean hydrogen, and we were paying £70 a kilo. There is no commercial model that makes it's madness. But there's just the scale we're now operating at, which, as I say, is still relatively small, but we have seen that price curve come down enormously, so below £50 a kilo. That was a moment, still ridiculous, the economics are not great, but absolutely today we have got enough infrastructure, we've got scale at the point, and also the reliability, just doing efficiently what hasn't been done before, just putting processes in place to be producing on an industrial basis, bringing just normal industry standards to an industry that didn't exist. We're now at that price point where we are absolutely able to offer pricing which is comparative over the long term with diesel. And that's an incredible place to be. And that's just been in those short years since 2019. So,
yeah. Okay. And that sort of brings me on to where we see things going over the next, 5-10 years, really. So, I mean, I don't know if you want to continue, Matt, with that, where you see, you just talked about sort of the pricing, where it's come from. So where do we see things progressing, not just on price, but in how we see hydrogen in the UK rail industry over the next few years?
So from my vantage point, which, as I say, is very GeoPura focused, and with our partner Siemens Energy, it feels like I've already mentioned this tipping point. It feels like what was once talked about conceptually is no longer conceptual. We're doing this. We're doing it every day. We're doing it reliably. We're serving markets, customers, very well-known folks, the BBC, Netflix, Belfer BT, our Royal Air Force, as I say. These are customers that they have to have a service which was as good as they had, and we're at the point where we're delivering that, and it's better, and they're willing to pay. As long as we can continue to build that trust in the marketplace and have real customers really prepared to actually put real money into this stuff, not just on an R&D basis, but in real terms, which they're doing, we will continue to grow. And the scale we're now at, the costs with where they're now at, mean we can enter these much larger markets, supporting things like data centers, incredibly power hungry. Boy, does the economy in this country, we need to be at the forefront of that data center revolution. We all know that the grid's constrained. Suddenly, the hydrogen provides a key to unlock that. In doing that, of course, then it also changes the economic situation for all these other industries. I can't see any way that rail can't play a significant role in distribution of hydrogen. And even if we end up just taking 5% of the energy mix in this country, hydrogen is likely to do that. Probably significantly more than that. Rail is going to be a key partner in distributing that, and hopefully bring real commerciality and real sustainability to rolling stock and to our friends at Heavy Haul Rail and others as well. So,
Mark, do you want to?
Yeah, I'd agree. I think I'd like to see not only the first full-scale train running with a full cargo of hydrogen, but also that being a regular repeating thing that grows and grows and grows. And as Matt sort of mentioned there are customers out there taking it and using it and thinking this is the next big thing. It's the case now to go and engage with those customers to say to them, okay, you've got one small facility that is using this. How about you take a full train's worth? How about your entire production facility potentially is powered by this material? Great, you're next to a railhead or you're near a container facility, whatever the transport method ends up being, but we can do this, and it is something that is going to drive you forward into the future, and it's going to be not only good for your business in terms of allowing you to scale and grow, but it also ticks all those boxes that are required these days, which is environmentally sound, and it's going to help us deliver what is needed to keep the economy going. I think it's a real opportunity.
Great. Ben?
I think in 5 years' time, it would be fantastic to see a train procurement launched for a fleet. I know that's not necessarily earmarked in the very near term, in the short term, but we've got a lot of diesel fleets ultimately to replace. There's a long-term rolling stock strategy that's due in the summer, and it'd be good in 5 years' time to see a procurement being launched. I think, and in parallel to that, over that period of time, I do think we will see further progression in other industries as well that I think will help to build confidence that it becomes more and more credible alongside some of the real big picture political and energy points that Charles spoke to.
Yeah. And Charles?
Certainly something I want to see in the next year, let alone the next 5 years, is a hydrogen shunter in operation. Commercially, of course. I wouldn't be doing my job if I didn't say that. Currently, our shunter is in test at Kidderminster, if anyone wants to come and see it, operating with greater speed, greater confidence, greater loads all the time, then you're absolutely welcome to. Hydro shunter is it's a retractioning, it's not a rebuilding. So if anyone here does have to have a shunter that is looking ropey in terms of its reliability, it's got obsolescence issues, our system is modular, and we can tailor it to most needs. But it's that starting small and building out. Big things have got little beginnings. We don't need to deploy a fleet. Shunters do get deployed in penny packets of 1s and 2s. So we do have a very deployable solution. And what I want to see over the next 5 years is starting with that small commercial use of shunters and ideally passenger trains, and it growing to be more ubiquitous. Is it going to be 50%, 75%, 100% of all trains? No, it's not. It's going to be a relative niche. Most trains now are electrified. 50% of the network's electrified, but roughly 66% trains are electric because that's where the density is. But there are key parts of the country where decarbonisation and deglobalisation of the energy supply is possible, such as the west of Wales, the north of Scotland. And I would love to see at least one of those routes get hydrogenised or decarbonised by any other measure in the next 5 years.
Great, thank you. Right, we've got just over 10 minutes left. Now, I don't know if there's a microphone about. For any questions from the audience? Has anyone got anything they'd like to ask the panel? Yes. You can just say who you are, where you're from as well. That would be great.
Hi, thank you. Good morning still. Adam Holyoke, I'm from Network Rail. I'm interested in this because I've just completed my master's in rail systems engineering, actually, and my dissertation was on decarbonisation of rail freight depots. So I've got two questions. Number one, how are you going to cope with the energy density problem of hydrogen and storage, because we know it likes to bond to other things? And secondly, if we're looking at whether it be hydrogen combustion or hydrogen fuel cells, I'll be looking at total life cycle impact of that, because people talk about batteries being, carbon neutral or carbon negative. That's complete lies, because making a lithium-ion battery is incredibly dirty making it, and you can't recycle them. So how is hydrogen going to be different?
Who wants to take that one first?
Perhaps I can speak to that a little bit. Certainly in terms of the energy density, it is a challenge, because when stored as gaseous hydrogen at 350 bar, it's no surprise that the equivalent amount of energy does take up more space than diesel fuel. That's obvious. In terms of our retrofit packages, such as Hydro Shunter, we can work around this by providing enough energy for the user's need over a daily duty cycle, for example. So very frequently what we get is, we need 22 hours a day operation, and we need to be refueling, servicing in that remainder 2 hours. We need to be cycling drivers through this thing and keeping the uptime as high as possible. So we're not going to last all week on a supply of hydrogen on Hydro Shunter as it stands right now. Other concepts are available. But we can do the duty cycle that the user requires. It's a bit like the difference between your iPhone and a Nokia 3310. Your 3310 would last all week on the charge, and you could throw it at a wall and it wouldn't break. Your iPhone lasts a day and you recharge it. So that's the difference there. Second question, can you remind me, please? Sorry.
It was talking about total life cycle of the carbon impact, because obviously things like lithium-ion batteries are actually very, very dirty. So how is things like hydrogen combustion or hydrogen fuel cells going to be different?
So I can't speak too greatly about hydrogen combustion. That's JCB's area more than my own, and other suppliers do exist. In terms of fuel cells, they're highly maintainable. They have a service life, and then you take them apart. You do a try to think of the right word here, but basically you can take them apart, recondition them, and get them back into service. But certainly something that we're seeing from our shunter and other applications is the shunter is actually primarily a battery shunter. That's what provides us with the whack of power that we need when we're getting a train rolling. And that's what you'll find from shunting applications is it's a short whack of power and then actually a low average power demand. So we take that whack of power and we slowly recharge. And that keeps the load on the battery nice and gentle. And whilst I can look up the figures and give it to you from the data sheet, it dramatically, like more than a figure of 3, elongates the life of our lead-acid battery. Similar effects will happen to lithium batteries. If you're operating battery only, the batteries get absolutely ragged, especially if you're using rapid charging, high C-rate charging. By keeping things as a hybrid, you're being more gentle to your battery and keeping everything operating to end of life for longer.
So I think you said your name was Adam. It sounds like you probably could come and help us as well with some of those challenges, more hurdles you were presenting. But in terms of storage, so what we've done at GeoPura, again, that word commercial, everything we've done really is the low-hanging fruit because we have to have an economic model around it that works. In terms of storage and distribution for us, that has meant we're basically filling tube trailers, and these are mostly HGV tube trailers, which become our storage vessels. So you feel a bit like milking your cow in the morning and filling your old milk tanker with milk. We're doing that with hydrogen, and then taking that to our end-use customer, and that becomes your storage. It then comes back empty, and we refill. We're working with folks like Cadent Gas, who are looking to put their pipeline network through High Marnham Power Station site, also down along the Thames from Tilbury. And they're talking to real engaged customers who want high-volume hydrogen. There will be, obviously, a need for greater storage associated if you're doing high-capacity hydrogen for firing of brick kilns or British Sugar or whatever, these industrial applications. And they're also looking then at salt caverns and the salt cavern network. So that's all longer term. But we see rail as being a unique in-between connector, if you like, in building a virtual pipeline. So if you could take what we're doing and just make 20-foot, 30-foot, and 40-foot road HGV tube trailers, but have a whole train load on that same principle, that becomes your storage. Well, that hydrogen is being moved to your wherever you're creating and generating your power. That is your storage, and so it's a very useful intermediary, and again, a great attraction to rail. Just on life cycle, again, I can only talk really from the fuel cell perspective as opposed to reciprocating engine, but our hydrogen power units, when we first delivered our commercial modelling back in 2019, we looked at a 10-year CapEx lifetime over each of our fuel cell products. We've got systems that have been running since 2019, so we're getting on more than way past the half duty life cycle, and they've been run hard. They've been run hard in real difficult commercial environments, high temperature ranges, cold temperature, you name it, filthy environments, and we're seeing them last and live up way beyond that initial 10-year depreciation CapEx life that we were expecting. So it's been quite encouraging. Again, it's early days. Nobody has used fuel cell at the scale and long duration, but 7 years in, it's looking pretty promising. And I think that we'd now be looking to do our CapEx modelling over a much longer time frame. That is also supported by financiers. We can raise debt finance against assets, which again I think speaks to the longevity and the fuel duty cycle use of a fuel cell-based system. So it's looking encouraging. You're welcome to come look, by the way. Come and visit. We'd love to have you.
Great. Anyone else? Question?
Thank you.
Yes. A gentleman in the corner was just picked, and then we'll come to after. Was it yourself, sir? Yeah.
Hiya, Mark Foot from Network Rail. I think it's just a few questions on sort of the feasibility of hydrogen, because obviously we have a lot of positive stories and we have a lot of negative stories. So obviously we have positive stories in we have eastern countries running hydrogen, don't we? And then we also have buses. So I sort of live in Crawley, and we've got hydrogen around there, and that's working quite well, apart from obviously what happened. But then also we have other stories, such as obviously what's happening in Germany, where they're moving away from hydrogen into batteries. So I think the question I've kind of got is, what have sort of each of your industries learned from sort of the good and sort of the bad experiences of what other people have dealt with when it comes to hydrogen, and how has that sort of influenced your work and research?
Okay. Anyone want to pick that one up first? And Ben,
I guess some of the parts of Europe are more electrified by default. So I guess battery electric trains are more of a natural choice, you would say. So obviously we are different here in the UK with a lack of electrification, and I pointed to some of those lessons, like where we've got a completely different gauge, haven't we? So again, sort of things like packaging are key lessons to learn. I think I guess breaking down that the chicken and egg of going back to getting to price point, I think that's always going to be sort of fundamental, and I do think that there's a neatness in being able to sort of generate locally around renewables, and transportation of hydrogen is one thing, but some of the suppliers that we've spoken with in terms of breaking that chicken and egg have been saying that maybe a fleet of 10 to 20 trains would be sufficient to justify the investment in putting down a local electrolyser. So, as I say, it's some of those projects that have been run elsewhere, as you said, on the continent, they've had more natural alternatives, I'd say, but I think we've got some bigger challenges on decarbonisation in the UK, so I think there's a fit.
Great. Does anyone else want to have anything to add on that?
I'd just quickly add to that. So just for us, it's all again about heading to what's commercial, what makes sense, because then obviously if there's an economic model, the proof's in the pudding, and somebody will fund it. Network Rail, of course, a huge landowner, huge assets. They've invested significantly in renewables. That hits the same problem. Anybody who's heavily investing in renewables, can you export that energy? Can you use all that energy? That creates opportunity for producing your own hydrogen, becoming a hydrogen producer. And then the question is, if you were Network Rail, what would you do with that hydrogen? The obvious thing would be, let's help run the network. Let's help, move away from diesel for generation. So really exciting. And again, commerciality is what can drive that.
Yeah. Great. Well, I think, we'll move to the gentleman in the middle there, and then this might be the last question. We'll see how we go on. Then
Hello, my name is Alex. I work with ABB, looking after the rail and rolling stock side of the business. My question is, how different are the maintenance regime for hydrogen units compared to, say, diesel or EMUs? And then the second question will be, what sort of operational challenges do the TOCs face when they're trying to integrate the hydrogen units to mixed fleets?
who wants to?
That one might be me.
Yeah.
I can't speak greatly about the maintenance of diesel trains. My career has been in hydrogen-powered trains. But certainly in terms of the amount of things to go wrong with a hydrogen-powered train, it's far smaller than that for a diesel. We don't have pistons moving up and down at thousands of times per minute, for example. No metal-on-metal contacts. The moving parts are coolant pumps and a blower, a rotary blower. So in terms of fuel cell maintenance, it's easy to the point at which on Hydroflex 1 days, I was trained to be a fuel cell maintainer. And trust me, I am not the best maintainer in the world. I could not do a diesel engine whatsoever, but I can do a fuel cell. I was trained in how to use or rather how to do the servicing on that fuel cell. And it was very simple, very few items. So I'd say the maintenance demand is naturally greater than that of an EMU, but somebody else can speak intelligently about the maintenance of a diesel train, a diesel unit, but it would be less than that. We also come in a highly modular package, so to a certain extent, if we need to remove bits, if we need to remove the fuel cell, we can do so quickly and easily. It's small and light. So that also helps with maintainability. And come to think of it, I will speak about the preparation of shunters, which is something I know about. It's a 20-odd minute task, there and thereabouts, from what I've seen at the Severn Valley, where we're testing shunter to get a diesel shunter up and running. For us, it's more like turning a switch and waiting for the air to blow open. So much less pumping of lubricants, pumping of coolant, so on and so forth. It's there, it's a case of turn the switch and by and large away you go.
Good. Great. I think that's pretty much bang on 12 o'clock. So thank you to our panel. Can we give them a hand? I'm sure if you want to ask them anything else afterwards, they'll be about. GeoPura and Heavy Haul are down at the front. You'll see the 66 and the wagons. Charles, you back for the day, Charles? Ben, if anyone's got any questions, they'll be able to find you in the day. So yeah, great. Thank you very much.